This is Note-Taking Guide 3.9 for Math 1. So what we're going to do today is we're going to just look at a couple of different functions and compare them in the way that we're asked to. So here I have a set of values, a table of values here for function 1. And here I have a graph of ordered pairs for a function number 2. So what I'm going to do is I'm going to take those two functions and I'm going to answer these questions over here. So the first question says, which function has the graph with a y-intercept furthest away from 0? So if I want to know the y-intercept, that's when my x value is equal to 0. So it's really easy to see right here on the table. My y-intercept is 7. On a graph, if I'm looking for my y-intercept, it's where my graph touches or crosses the y-axis. So here on this graph, my y-intercept is 7. So the question says, which one of these functions has the y-intercept that's furthest away from 0? Well, the one that's farthest away from 0 is 7. So that would be function 1 for my answer. The next question says, which function's graph is the steepest? Well, in order to figure out which one is the steepest, we would have to figure out the slope. So on a slope formula here, it would be y2 minus y1 over x2 minus x1. I can pick any of my ordered pairs in order to do that, and then I just put them through that slope formula. So I'm going to go 5 minus 7 for my y's, and then 1 minus 0 for my x's. So on top I get negative 2, on bottom I get 1, so my slope is a negative 2 on this top function, function 1. On my next function, I'm going to count my slope. It's going to be down 1, down 2, and over 1, 2, 3. So down 2 and over 3. Which function's graph is the steepest? The steepest would be the biggest number. This number is negative 2. This number is not quite 1. It's a negative 2/3. So again, function 1 is going to be the steepest in this case. The third and final question on this says, which function have graphs with y-intercepts greater than 4? Well, we already looked at the y-intercept here, it was 7. We already looked at the y-intercept here, and its y-intercept was 5. So we know that both function 1 and function 2 have y-intercepts that are greater than 4. All right, this next one just says, which function grows faster? So how are we going to tell which one grows faster? We're going to just substitute some numbers into these ordered pair table of values here, and we're going to decide which one grows faster. So let's put 0 in first. So we would go 3 to the 0 power, and we would get out 1. Let's put in 1. If we go 3 to the 1 power, we get out 3. Let's go 2. 3 to the 2nd power, we get out 9. Let's put in 3. 3 to the 3rd power, we get out 27. And let's put in 4. 3 to the 4th power is 81. So there's our table of values filled out down here. Now it's important that we use the same set of values for our x's on the second function, or we're not really comparing like things. So we're going to do 0, 1, 2, 3, and 4 again, substituting into this function to see which one grows faster. So we'll go 100 times 2 to the 0. 2 to the 0 is 1, so 1 times 100 is 100. Now if we look at the value of the top function and the bottom function just at that value, then the second function is bigger because it's at 100 and the first function is only at 1. But let's go and see what happens next. So we put 100 in, so we put 1 in, so 100 times 2 to the 1st power. So that, when we put it in our calculator, gives us out 200. Okay, let's put 2 in and see what happens. 100 times 2 to the 2nd power. So this is going to be 4. 4 times 100 is 400. Then we're going to put in 3. So 3 times 2 to the 3rd power. 2 to the 3rd power is 8. 8 times 100 is 800. And then the next one is 4. So 100 times 2 to the 4th power. 2 to the 4th power is 16. 16 times 100 is 1600. So the question is, which one is growing faster? Well, if I look right here, when I go from 1 to 3, I grow by timesing by 3. Here I grow by timesing by 3. Here I grow by timesing by 3. Am I getting the same thing here? Here I times by 2 to get from here to here. Here I times by 2, here I times by 2, and here I times by 2. So which function actually grows faster to get from one ordered pair to the next? It's actually this top function up here, function 1, because its slope or average rate of change is a bigger number than the bottom's slope or average rate of change. So today on your assignment, you're going to be asked lots of different questions about two functions. You're just going to compare them together and see the common things, the differences, and answer the questions accordingly. Thanks for watching, you guys. Good luck on your homework.